Hello everyone, this is Mark Kardashov, and I am one of the co-founders of TestProject. We have Marat Strelets on the line as well, and Karen from TestProject. Marat will host most of this session. So in this particular session, Marat will present how to utilize TestProject SDK with page objects pattern methodology. So Marat, please take it from here.
Thank you, Mark. So yeah, hi everyone, I'm Marat, and as Mark said, I will be presenting most of the following agenda. And we are actually going to start with a simple test. Whoever is familiar with the Selenium commands will easily understand what's going on here. This test is a basic example of how to use our SDK to create a web test. And you can find it on our GitHub page. We'll send out the links at the end of this demonstration. What's happening here is that we obtain an instance of a driver. And we are using pure Selenium to navigate to some web page, input data, and eventually we compare some text one with another in order to decide if the test has passed or failed. So the only difference here is probably that worth mentioning between a regular Selenium test and what's happening here is that you don't have to choose which kind of driver you are going to initialize. This decision will come later when this test will be executed on our platform, and you will be able to select any browser or any driver that is already installed on your computer. So from this point, we'll move forward, and I'm going to show you a little bit more advanced scenario that, as Musk said, is based on the page object pattern and is a test for the Google Translate application. What it does, it actually translates some text from English into a different language, and then it copies the translation and translates it back from the target language to the source language, testing if the translations are equal. So as you can see here, this class that's called Google Translate Test, it extends our framework and SDK class called a test. And because it's doing so, it must implement the execute method. The execute method is actually the core of the test that is going to be executed. Something else that you can see here is that it implements a functional test. A functional test, from our perspective, is a test that is divided into small building blocks. And in this particular case, it is divided into steps. So looking at this left side, you can see that the structure of the folders in this test is separated into tests, steps, and pages. While the test is the file that you can see right now, steps are the building blocks of what is going to happen here, and pages are actually the page object pattern implementation. If you have a look at this function here, called add reusable steps, which is also an override of the test class, is actually a list of steps that are going to be performed here. The application will be, oh, just a second. I'm sorry, guys. This is the Android test that I wanted to talk to you about a little bit later, but this is the right one. So it is almost identical, so we didn't miss anything. We are looking currently at the list of steps that are going to be executed. It will open the Google website, input some information, copy some information, and then eventually compare the results. So what I want to show you before we actually dive into each of these steps is that there is also some metadata shown here in these annotations that allow you to decorate your test and allow some configuration. In this particular case, we can see some input parameters, but it can, of course, be output parameters that will be eventually outputted from the test into a different flow in case needed. So let's open a single step just to see how it looks like. This first step is actually the step that navigates to the Google web page, and it extends the functional step class. You can see that there are three functions that needs to be implemented here. These are abstract functions. One of them is the get description that will allow us seeing this step description later in the reports after the platform executes the step. The second one is the validate function. The validate function is being executed before the step is being executed. And it's made in order to make sure that the input information coming into this step is accurate and valid before the step is actually executed. In case it's wrong or empty, the step will not even attempt to be executed and of course will fail. You will be able to see that it failed on the validation stage later in the reports. In this particular case, it just validates that the URL supplied is a valid URL. But in case your step is not intended to validate anything, you can always just return true from this function and move forward to the execution itself implemented in the run method. So as I was saying, in this case, the run method is actually obtaining an instance of the WebDriver, because this is a web test in our case, and navigates to the URL provided. This is the core logic of the step itself. And if we will go back to the test and open the second step, we are able to see that it's relatively small. There's nothing too sophisticated going on here besides the description itself. And this step is actually using the page object pattern. And since Google Translate application website is actually a single page application, in this case, in the pages section, we got only one page. But later on, we will be showing an Android test, and you will see that it has much more pages. Almost I can say that a page per an activity. So what's going on here is that a new instance of this page is being initialized. And I would like to show you what the main page class looks like. It extends the base page class and declares that it's going to be a web page. So these here are basically the page object implementation, which are the elements that are going to be located on the page. The idea behind this whole framework, as Mark said, it's not something that we enforce, but the idea is to break your test into small components so that whenever a change is required, because something changes in the application or in the environment, you will be able to easily find the exact place where the definition is happening. So in this particular case, you won't have to change anything in the test or the steps. All you have to do in case that an element changes its location strategy, for example, from ID to XPath or CSS locator, you will just come over here and change this location in this annotation from Selenium from find by. And the rest here is actually the functions that are being performed on the elements. We'll have a look at them in a moment. Just one thing that left to discuss is actually the get identifying element method that needs to be implemented coming from the base page, where I return in this particular case, this app name element. This is the unique element that identifies the page and makes sure that before any action takes place, the application is currently showing the exact UI you are planning to work on. So if this function will fail to obtain an instance of an element, the test will not proceed and fail accordingly, saying that the page is a different page. In case you need to identify your page using multiple elements or using some kind of a different approach, any test can actually override a method called isLoaded, which I will show you a bit later, and put some different logic in this method instead of just calling the get identifying element function. So as I was saying, these all are actually the core of your automation. As you can see, we are utilizing the pre-mapped elements, pre-initialized elements of the page, and some of these functions just click these elements, some of them input text, and some of them are getting text from these labels or other web elements that are being used here. So as I was saying, this is the basic structure of a test that we suggest to use. We believe after many years of experience that this is something which is modular enough in order to allow you maintaining this code for the long run. And if I'm going back to the test here, you can see that there are some steps that currently receive inputs into the constructors. And some of them are even getting additional parameters, such as, for example, this enum here, which allows you to specify that after execution of this step, instead of using the default mechanism of taking screenshot only on failures, you can even take screenshots on success scenarios as well. Besides this, we have implemented many different built-in steps that allow us to add such things, for example, as pause. Okay, sometimes you need, give me a second here. Okay, sometimes you need to pause your execution in order to wait for some kind of an activity to happen, not for an element to be found. We're going to discuss this right now, but you would like to pause it for a second, for example. There is a built-in step for pause step. It's not among these steps, it's part of our framework. We will see in the Android example, there are many others, such as resetting an application or launching an application and so on. And instead of adding, for example, multiple steps, you can always specify the amount of repeats that this step will be executed. So in this case, I just specified that this step will be executed twice. There are also other overloads, such as conditions that allow us to execute step based on some criteria that can be evaluated in runtime, and so on, etc. So this is the Fluent API that we call the functional test builder that we suggest using. You can still get and use pure Selenium, but this is something that proved as a working mechanism, and we really encouraged you to be using these kind of things. So I just want to move forward and show you how, when a test is already written and you are ready for an execution, since any test usually is executed by platform, or if in case that this is an execution mechanism such as JUnit, it got its own execution entry point. So if you can see, this test neither have a main method that can be executed from a command line or from any IDE. And by the way, I'm currently using the IntelliJ IDEA Studio, but you can of course go ahead and use any kind of IDE you want, would be Eclipse or anything else. This example is just a Gradle project, so you can always import it and build your own environment to get it tested. So our suggestion, and again, it's only a suggestion, you can do it otherwise, is creating an additional project called Runner project. This project is actually a very simple implementation of a class with a main method that will be executed when you're going to run this application. It also references the TestProject SDK, and of course it references the first project, the test itself. And what's happening here is that we are currently deciding in development time only that we are going to use the Chrome browser, and we are going to initialize the class called TestProject Runner with some security measures that we got with the developer token, which can be obtained from the developer portal on our website, just to make sure that you are actually allowed to use this particular agent that is going to be the execution engine for this test, and supply some information about the test that you are going to execute. Then it executes the test using the run method, and you can actually see it running on your computer. So let's go ahead and try to execute it. If I'm going to use the debug option, you can of course put breakpoints into the test, and you can debug it live while it's being executed. So at this point, we'll just execute it using the run option, and you will see that at some point, a browser will pop up. This test will run, input all the information, and translate it into one direction, then into another direction, and eventually compare the results. So it compares hello world with hello world, and since they're equal, this test can be considered as a successful test. And just one tiny thing that I would like to show you before we move forward is that the step of comparing tests, comparing the results of the translation, in its run method, instead of returning just a Boolean, it uses this pass and fail functions. So in case of failure, if these two values would not be equal, the fail function is actually asserting some kind of a message about the failure back to the reporting mechanism. And we will be able to see later in the report section that all this information has been reflected, and you can easily track what was the exact reason why your automation has failed. So at this point, when we saw how to write basic web test and how to debug it while you are developing it, I think it's about time that we can now move forward and we can actually see how can we upload this test to the TestProject platform and run it from the platform. So the outcome of any Java project is basically a jar file. And in this particular case, we got only one test in this project, but we could also generate a jar file with multiple tests into a single jar file and upload the single jar file in order to get it executed on our platform one by one. And I'll just switch my configuration here to jar. And now I would like to move forward to our application UI, showing you just a few things if you are not familiar with it, or even if you are, how it exactly works. So this is our dashboard here. This is the main page. And what you can see here is that we got a project, what was created specifically for the purposes of this webinar, called the demo project. And I'm going to open it. And the project is basically an aggregation of multiple tests and jobs. We are going to discuss what a job is in a moment. To allow you separating your test automation logically. It can be separation based on application type, based on a sequence or a version, and so on. So what we can see here is just an example of a few demo tests and jobs. While a test is the basic flow of an automation sequence, and a job is an aggregation of multiple tests into a group where the tests are going to be executed one after another. So first, what we will do, we will expand the test packages part of this view, and we are going to create a new test packages. And as I was saying, a test package is basically a jar file that can contain one or more coded tests. So in this case, we have developed a web test, and I'm going to name it accordingly. It's a Google Translate test. And now I'm going to upload the jar file that I just compiled in order to show you how it happens. So we got it right here. Here we go. Once you upload it, if you will have a look, there's some metadata information that appears here. This information comes from your test. So these parameters here, these are basically the annotations that I talked to you about a little bit earlier, where we specified what are the incoming and outcoming parameters for this test. And in this case, we got only one test inside. So I'll just will continue. And what's going to happen is that this package will now appear in the list of test packages. And when expanded, I will be able to see the tests that are residing in this jar file. When I will click it, it will move the screen to a different view where I can see actually the test that currently resides in this package and the jobs, of course. So I can either execute this test directly using this play button here, okay? And what you can see now is actually one of our greatest abilities of the platform is that I can execute it not only on the TestProject agent, which is currently installed on my computer, but possibly if there will be more agents here, which are distributed all over the world, for example, I can go ahead and execute this test on any remote agent located anywhere in the world as long as it is associated with my TestProject account. So this is very convenient when you are testing, like, for example, mobile applications, and you don't necessarily have all the devices physically available in your location. You can go ahead and execute it somewhere remotely. Or in case of web applications, when you would like to test how your application behaves from different locations when you don't get access to CDNs and so on. So in this particular case, I got currently only one agent appearing here, which is actually my demo agent that I'm currently working on. It's installed on my computer. And right now I can choose from the list of browsers that are currently installed on my computer. So this is one of the options. And as I was saying before, sometimes you would like to execute a series of tests from within a job on a different target. So what I'm going to do, instead of executing this test directly, I'm going to create a new job. I'm going to call it a demo job. And I'm going to specify that this is a web job, which will be executed on my agent. And it will be executed on all those three browsers. I can also specify that this job will be executed using a schedule. It can be a one-time schedule at specific time. It also can be a recurring schedule executed based on your preferences whenever you want your execution and automation to happen. But in this case, we'll just leave it as on-demand execution. And now, when a job has been created, it has no tests inside. I can just drag this test into the job, and I can execute it later on by dragging more tests into the job and either relying on a schedule or just executing it using this play button. Before we continue to other things, I just want to make the whole picture a little bit clearer to you about what you are seeing in this screen. So as we were saying, this is the tests that currently residing in the package, and these are the jobs. But there are a few more things here, like, for example, the elements, which are like page object elements for recorded tests. We'll get there as soon as we will showing the recording studio. These are the applications. Primarily, it's mobile applications that your current project is currently executing the automation on. There are the data sources, which allow you to specify a list from external parameters, such as a CSV or an Excel file, when you can use to execute the same test in a job, for example, using different data each time it's being executed. And there are the general parameters for the project for scenarios when you have some kind of a parameter of local environment, for example, or some local definition of something that is useful for all the tests in this project. So before going ahead, I'm just going to switch back really quickly to our agenda. Just to summarize what we saw until so far, I was talking about developing a web test, debugging a web test using the TestProject Runner. We saw some overview of the TestProject UI and how to upload and run a testing job. So before we proceed to the Android test, let me really quickly just execute this from here so you can get the understanding of what I'm talking about. We were here in the Google Translate test. And as I was saying, I can execute it on my local agent, but now I'm going to execute it on Firefox. And now it's going to show me the default values of the parameters that I have supplied, and they're coming from code. So all these are being reflected into the UI later. And as I was saying, I can override these parameters with an external data source to make my execution data-driven. So I'm going to leave it as default, and I'm going to execute it. And you will see in a moment that the Firefox window is being opened on my computer. I'll just drag it to this screen. And then this test is being executed. Eventually, after the execution of this test, when it's executed from the platform, we will be able to see a report of the execution results. And of course, in case of failure, we would be able to see the reason why this failure actually happened. So I'm going to switch really quickly before we go ahead and see the Android test to the reports model. And we got the demo project here. We also got this execution here, which happened just now. And we can see that this test has been executed on the Firefox browser. And these are all the steps that have been created in code in order to achieve the requested goal. So eventually, these two strings, hello world, were compared, and the compare resulted in a success. So from this perspective, everything is fine. And of course, in case of failure and in case something is configured differently, for example, in this case, if you remember, the get translated text was configured with an overload for screenshot. We can see a screenshot of what was happening exactly in the browser in case we would like to know a little bit better. So in this case, everything was fine, hello world, and some translation in a foreign language. So at this point, we are moving forward to seeing an Android test, which is almost identical to the web test. But the major difference here is that, of course, it's different steps because we need to operate different elements. But this test has much more pages in this area. So the page object pattern is much more applicable for Appium tests rather than single page applications. Even though we can still separate it into different page objects in case of pop-ups and dialogues. But in this particular case, we got the main page with its own list of objects identified by Android find by annotation, and some actions that are taking place in order to achieve the required goals, such as clicking these elements and getting their text and so on. And we also got some different pages for example, the language choosing page that got its own object and its own identifier for the unique element in order to make sure that we're currently seeing the right page. So this is the major difference. And the only, I would say, discrepancy between the structure of this kind of test and web test would be probably in the runner, which is not a part of your test actually, because as we said, the platform executes it. Because in this case, the only difference is that you have to specify the application details that you are going to execute the test on. But besides this, it's almost identical, as I was saying, to the web test. So once it's compiled and deployed as a jar file, this project, the runner project, is not a part of it, but we provide this information as the part of our platform. So whenever you actually want to execute a mobile test, for example, this test, okay, this is an iOS test that we are going to see really soon, how it's being created and how it's being recorded in this case. We're not going to develop a coded test, but just using our recording studio and Spy in order to see how it works. And we're going to do this on Windows, of course, just to emphasize that we are able to do this kind of things. So as I was saying, the only difference here is that you have to specify some kind of an entry point for the application part. So when this test was created, there was some entity created called the Google Translate application, and this can be either iOS or Android and so on. And just to make sure that it really works, I can get this information really easily from my already connected device. So this is a mobile device which is currently connected to my agent. And before we proceed, I just want to show you a couple of things here in the UI about what are these. So this section here, the agent section, shows you a list of agents associated with your account. But besides showing just the name and who is the owner, you can also see that we got all these browsers currently installed on my agent. And also we got all these devices connected to my agent. So we can easily see the remote mirroring of the device. So I'm going just really quickly to show you what I'm talking about. I'm currently trying to view my local device screen. And if you can see, I'm currently moving things on the screen physically, and you can see the screen changing on your side. So I can do the same thing from here, from the mirroring. Okay, I'm swiping the screen, and this is what's happening. Okay, so this is really convenient when you got devices connected to some agent, which is not physically located in the room you are working from. It's really convenient to operate these kind of devices using this technique. So it can be applicable, of course, also for Android devices and for iOS devices. Okay, but in this particular case, currently you are seeing how things are working on my Mac computer. And for the automation that Appium uses, you need to have an Xcode installed. So what we did, we moved forward, and soon I'm going to show you it. We removed the requirement of having an Xcode installed on your computer, And we allowed you to actually perform the operations without having the need of a Mac computer in order to create the automation for iOS. Okay, so just an example of how I can operate an iOS device connected either to my computer or some other agent. Okay, so at this point, going back to the agenda, is that we are going to talk about how to record and how to find out about the different elements of an application so that we can utilize this information in coded tests and also allow you to create tests which are not based on code. So if you give me a moment here, I'm going to turn on my virtual machine. Mark, I think this is the time when you can step in if there's anything you would like to add, or you guys, if you have any questions, you can go ahead and ask them right now while I'm turning things on here really quickly.
Yeah, Marat, I think there is one question from Anton that you can address. Besides it, maybe it's a good idea to just briefly explain on what are the main components of TestProject framework, including the agent and the web interface and the SDK, and how all of them works together. Just to put things in order for the guys, because I'm not sure if everyone here is on the same page about how the framework works and where the executions happens.
Yeah, it's a very good point here that Mark is actually referring to. So the major obstacle is usually that the backend servers are located in some kind of an intranet and are not available for communication from outside. So any other automation platform that actually requires you to expose your application in development to the outer world creates an obstacle. But there are solutions. In our case, the TestProject agent is a tiny utility with a very low footprint that is running on your computer, and this is actually the only thing that is running on your computer, that allows you not only to execute the test, but also to provide some additional capabilities such as execution, recording, and development. And what it allows you to do actually is that all your activities and all the information that you are storing are not located in one particular location. It can be distributed between different edges, as I was saying. Your coded tests that you upload, the jar files, are being distributed to the agents which are executing this test. The data source files are also distributed. All the information about the objects that we are going to create now when we are recording a test, everything is being distributed to these endpoints, but all the major data and all the major processing is happening on our servers. We provide the capability through the website to design, to develop, and to record all the activities for your test automation. So the idea behind this topology is that we basically have the backend servers, where all the big data processing is happening. We have the web UI running in your browser, and we got the end tools, such as your IDE, for example, that communicates with our TestProject agent in order to provide the capabilities for development and execution. Okay, so this is a very high level of what's going on here, but this is very convenient when you got an utility locally to execute your test instead of executing it somewhere else. And this is exactly what our TestProject agent is doing. So
yeah, I think, Marat, the bottom line, just to simplify your explanation, the bottom line, all you need to do is just register to TestProject, have an account, and download the agent locally. And once the agent is downloaded and installed on your local desktop, again, we support all platforms, Linux, macOS, and Windows, and it's registered with your account. It already contains all the SDKs and all the drivers that needed in order to develop the automation. So you don't need to worry about downloading the last Appium version or downloading particular Selenium driver for particular browser. Everything already built and packed in TestProject installation. So not only the setup is more easy and more convenient, you don't need to configure anything. You don't need to configure Appium. Everything is done on behalf of you by the TestProject agent. All of the configuration are taken care by TestProject agent. So once you install it, you have all you need to start or develop your test automation by coding, or start to recording your test automation with the recording studio. I think Marat, Anton addressed a question in chat. Can
Yeah,
you
let's
please?
talk about it just a bit.
Yeah.
So the question, Anton, if I'm not mistaken here, is like the test object UI. You are referring to a recorded test. You would like to extract the list of steps, or can you please elaborate on the question just a bit to get it more so I can.
Marat, I think that Anton means that we will wait for his elaboration, but I think what he actually means that once the test is recorded, is there any way to get the code, the actual code, like to get the actual Java code from the recorded actions?
Yeah, I understand it. There are different approaches, like, for example, seeing our reports through continuous integration. This is something that we are going to talk about. So you can examine the execution results from your tools such as Jenkins, for example, or anything else that runs your continuous integration today. And you can examine the results, including the errors and many other things. You don't necessarily have to use our reporting platform.
No, Marat, I think you miss the point. I think that what Anton referring is, if I understand it correctly, is once you use the recorder and a step was recorded via recorder, is there any way to translate those recorded steps to the actual code? I think if this is the question, the answer is no. You can't, yeah, I see Anton's answer. Yeah, I got it. Yeah, you can't do a reverse engineering. You can't take a recorded test and create a code, but it's a nice feature, and it's coming from several of our customers and several of test automation experts from the community. So I guess we will implement it because it's not that hard. So currently this is not available, but I believe that it will be available very soon.
Yes, so probably Mark is on this. Give me just one more second here. Maybe it's a good idea if we will talk now about the continuous integration and the API before my virtual machine here decides to come up. Just a second. So I wanted to show you the capabilities of operating our external API to trigger the jobs execution. So for example, if you already have an automation in place and you got all the jobs in some kind of an automation orchestration tool. So this is an example of an endpoint that is being invoked using an API key. And in a second, I will show you how to obtain such. That can return a list of existing jobs. So if I just execute it right now, you can see that we have 3 jobs here, and one of them is actually the demo job that I just created a little bit earlier. And in order to get the API key that you can use in order to get the list of jobs and execute a job, is that you can open your account settings, and you can open the member section and then the API keys. And if you can see, you already have one here, but you can create more API keys and just then copy the value from here and use it in your API request. So this is the way that you can actually incorporate an already existing flow into executing the tests that you can convert to be used with TestProject and then execute on our platform. We have our GitHub page where you can see more of the demo tests that we have created, and some explanation about the APIs there as well. Still can make the windows work. So just to emphasize it, probably would be necessary to doing it. I'll have to reset the machine. It will take another minute. So Mark, you can take the stage meanwhile I'm doing this.
Yeah. What Marat is about to show you is, I guess he's trying to wake up his virtual machine, which is actually Microsoft Windows. And one of the enhancements that we added to TestProject agent and the TestProject framework is the ability to develop, execute, or record iOS tests from Windows without having any dependencies that usually come with it. So we just added some tweaks and improvements on top of Appium that allows you guys to plug your iOS mobile to your Windows in case you have Windows or not Mac or Linux operation system and desktop, and develop test automation from your Windows on the iOS. In case you prefer to record and not develop your tests, in case it's a simple test and just want to make something quick and dirty, you can also record your test automation from Windows on your iOS device. So until now, very few frameworks allow this this option, and we allow it, and basically you can use it free with TestProject, and it should make your life be more easy and convenient. So Marat, if you still can't wake up your Windows machine, we can go ahead and record any other test from iOS from your Mac, or and I think everyone here can just try to do it from the Windows, and it should work. It's not an issue.
Yeah, for some reason, just starting now to restart itself and update itself. So it's probably
it's Microsoft Windows.
Yeah. So yeah, so you'll probably go back to, I just turned it off. I will go back to doing it on my physical computer. And as Mark was saying, I'm going to open an existing test here.
Not before you will address another questions from
another question indeed. Yeah. It's possible to fix change API tests already added to TestProject UI. Pets in test, I mean. So the idea behind testing an API is actually by invoking, if it's a RESTful API, we are working on such a capability, and this is the greatness of our platform. We actually allow people to extend it with different plugins and, as we call them, add-ons to allow this kind of a capability. So we are going to release a generic plugin for API testing very, very soon. And the testing itself can be done in a coded test or a recorded test. But about fixing and changing API tests.
Yeah, Marat, I think what Anton is actually referring to, and I speak for him again, is and Anton, correct me if I'm wrong, if when it's not necessarily API, what do you mean API? It's not REST API. I think what you mean is when you upload your coded test package, the binaries, to the test project platform, is there any way to change it without re-uploading those binaries once again? I think this is the, yeah, I think the bottom line, if we have any IDE, in-browser IDE that allows us to, make changes in those binaries. So Anton, I will answer this question for you. So the answer is no. Once the binaries are uploaded, we generated by some reflection methods the metadata and everything we need from those binaries. And if you make any change in those binaries, you need to recompile them and re-upload them and have the latest tests in your UI. In our pipeline in the future, in the very near future, will be an ID available, in-browser ID available for languages that is not required a compilation, such as JavaScript or Groovy or Python. So you will have an IDE for future and additional TestProject SDKs that will be released soon. But for Java and the C# SDK, the C# is not released yet, but for Java SDK and those SDKs who require compilation, there is no option to edit those tests. You need to re-upload them and make sure that you have the latest version available.
Yes, thank you, Mark. So indeed, these are currently compiled code. So this is basically the reason behind this. But so going back to what I wanted to show you, what we can see right now is actually the test project recording studio. As I was showing earlier, you can see a projection or a mirroring of your device here in the test project website, as long as this device is connected to your computer. And besides just seeing it and performing some basic actions such as clicking and swiping, there's some other addition here called the Test Project Spy, which is more like an evolution of the Appium Inspector, which allows you to see the properties and the metadata of the elements that you can operate with when you're creating your recorded test. So, for example, in this case, it's some kind of a button. We are using the XE UI testing framework behind the scenes for iOS. And we can perform different actions on this element, such as clicking it, getting its text, and different gestures, and so on. We can validate stuff, such as making sure it's present, for example, before we actually perform the operation itself. And we got the attributes. The attributes is the main source for the location strategy. So we could either use the generic XPath, would it be a hierarchical one, or we could just search for an element by its label, in this case, for example, an original language Russian, so on, or by its name, which is considered usually to be unique, as long as the developers are developing the application in this way. So the idea behind the spy is not only to let you record the scenario, but also to allow you playing with the application and discover all this information in order to create your coded tests, instead of analyzing the whole DOM or asking the developers what and how to identify every element when you are creating your automated tests. So when an operation is being performed, as you can see, there's a list of steps here, currently 15 steps. When an operation is being performed on some element, like for example, right now I'm going to click this switch languages button, and execution is actually happening on the device. You can see that this languages has swapped. Now it's English to Russian, and a new step has been created, click swap language button. So this is how the recorder works. And in this scenario is already recorded. I'm going to delete this unnecessary step. What's going on is that the same scenario that I have showed you for the website and for the Android application is currently recorded using this recording studio with different input parameters, such as source language, for example, or target language. And eventually, there's a step for comparing the two translations, and this is what defines if this test was successful or not. So I'm just going to execute this test from here, from within the recorder, and we can see live the operations are happening on the device.
So the device is, just to emphasize on the setup, we have an iOS device connected to Marat station, and those operations happens on real device, not an emulator, and they are really executed in real time right now. And currently we see a reflection of the execution, of the actual execution.
Yeah, so this is basically the scenario of translating this hello world into some direction, and vice versa. Yeah. I can just stop it. I can continue waiting for the execution to finish. But as you can see, once it's finished, these all steps here are marked with the green border. It means that they have passed successfully, and eventually the close up has just closed the application. So again, this is the recording studio, and it works seamlessly on Mac and Windows as long as Windows itself works. And this is about this part of our webinar. I'm going back to the agenda, and I guess that the last part needs to be covered really quickly is, oh, actually we already did this. Yeah, the part when I was showing you how to query the jobs and how to execute them based on your continuous integration setup.
Murat, can we go back to the project and jobs area? I want to just emphasize a little bit on a specific job, and let's take a sanity job for an example. So can you expand it, please?
Yeah,
so just,
of course.
Yes, just to emphasize a little bit on the job use. When you create a job, as Marat stated before, it's aggregation of several test cases that they can be recorded or coded. It's seamless from TestProject perspective, that will be running on a specific agent. And here you are creating the setup of your test automation execution. You're creating the test cases that's going to run. You're creating the actual agent that within your organization where it's going to be running. You add the data set in case you want to run a data-driven test, so you can decide on each test which parameters will be passed. You can create the configuration and what just Matt shown before, on which browsers or which devices the tester is going to run. So all of those are very useful methods and ways to run several tests on a specific device and or specific setup. And the very important part that is hidden here, that once the job will run, it will actually, the agent and the TestProject framework will actually make sure to download all the binaries and all the test cases and all the applications and all the APKs or whatever needed in order to run this job. So you don't need to take care of basically anything from this perspective. The old continuous integration parts and the DevOps work that usually, the glue that usually done by DevOps folks are already covered here. So since the agent and the job knows what parts and what binaries should be used in order to run specific tests, it will automatically download everything from the TestProject account and execute it, including the data source and everything else, and provide back the reports to the main dashboard screen. So from this perspective, you can really easy like establish a headless Linux machine or any other machine, Microsoft machine, and just make sure you have agent installed, and that's it. Once you install the agent and register it, you don't need to make any other configuration or copy tests manually or copy your data sets manually or other manual things. Everything is covered by the agent. This is the, I think this is the one of the greatest features here, that you can focus on the development of testing instead of using and like adjusting infrastructure to support it. This was my 50 cents about it.
Yes, thank you, Mark. So basically, I think that we have covered everything in the agenda of this session. If you have any questions, you can go ahead and ask them right now. We are going to send the link to our GitHub page so that you can review the samples. Feel free to register to TestProject and get a free account to start playing with it. I guess this is it. Mark?
Yeah, in case there is no any other questions, I would like to thank you, all of you guys, for participating this, guys and girls, for participating this session and participating this webinar. I hope it was educating, and thank you for your time. Marat, thank you for hosting this this webinar session. I found it very, very useful from my perspective. And Karen, thank you for arranging this webinar and scheduling and makes all the necessary preparation to make it happen. And thank you.
Yeah, thank you all. And I think that if you wait just 1 second, maybe, nope, Windows is dead. Okay, so until next time, guys. Thank you very much for your time, and thank you, everyone.
Bye-bye.
Bye-bye.